Welcome to the basics of network analysis. Now we are looking at source conversion techniques. Source conversion techniques are actually meant for simplifying the network analysis. We may convert a voltage source into an equivalent current source or a current source into an equivalent voltage source, if that simplifies our analysis. Remember that this is only a mathematical construction and we are actually making equivalent source for analysis purpose. In real or in practical, just by applying this technique, you can't convert a real current source into a voltage source or a voltage source into a current source. But this is for analysis and for simplifying the analysis. And it is also valid only at the terminals. You will know what it is by after seeing some examples. Suppose you have a voltage source. You know that the voltage source has an internal resistance or a resistance in series. So a voltage source in series with a resistance can be converted to an equivalent current source in parallel with the resistance. And the resistance will be same. The same resistance that is in series here will become parallel. And the value of the current source will be E by R. Voltage by resistance will be the current. And these two are equivalent for practical purposes. Similarly, you can also convert a current source. A current I and resistance are in parallel. A current source with a resistance in parallel can be converted to a voltage source in resistance, in a resistance that is in series with the voltage source. Again, R will be same, E equal to IR. Now, if you see these two are equivalent, you can convert this back or this to this. So a voltage source can be converted to a current source can be converted to a voltage source. Now let's see how it will simplify our analysis with the help of some examples. You have before even going to that simplification, first we will check its validity. Now you have a circuit here, very simple one. So 20 parallel 2010 plus 2030, 15 by 30, 0.5 milliamperes current, 0.5 milliampere will divide equally. So you see 0.25 milliamperes current in each branch. Here, for example, here 0.25 milliamperes is there. So if we want to do this problem by converting this voltage source into a current source. This voltage source is converted to a current source. As per the model I told you, it will be replaced by a current source in parallel with resistance. The value of resistance will remain same. And the current here 15 by 20. So this I prime and I double prime, they don't have an actual meaning. What I mean to say by saying that it is valid at terminals, these terminals and these terminals are equivalent. This current and this current are not same. Okay, they are not valid there. It's valid only at the terminals. Now if you replace the circuit back, here. Now you see all three are in parallel, 20s. So it will be divided by equally by 3. So 15 by 20 divided by 3, it will be also be 0.25 milliamperes. See, these two are same. Now suppose you have a circuit like this. You know, if there are two voltage sources, it is difficult to solve because you can't calculate total resistance. Either you have to apply mesh analysis, nodal analysis, or some theorems. We can also see whether source conversion helps. So this voltage source can be converted to a current source because 18 volt in series with 6. Here also 9 volt in series with 6. So if you convert, what will be the value of the resistance? It will remain 6 each. What will be the value of current? 18 by 6. It will be 3. 9 by 6. So 3 amperes, 1.5 amperes, and 3.6 resistance. Now you know parallel things are interchangeable or exchangeable. So I have just rearranged so that all of them, all current sources here, all resistors here. Now it is 4.5. It will divide equally into 3. Have another circuit here. There is a voltage source and also a current source. So we decided to convert this voltage source into an equivalent current source. So 18 by 3 is 6 and 3 will remain parallel. And now you can interchange. So 6 plus 2, 8 amperes is coming. These two are effectively 3. So 8 will divide into 4 and that 4 will again divide it into like a 2. 2 amperes is coming. You may try some problems from these books. Thank you very much.